Good evening, guys. Hope I'm audible to you. So today's our topic is technology. So we are in the topic of different types of microcontrollers. So today our subtopic in different types of microcontrollers is an MCU. So after after the last class, we learned about the types of the other two types of microcontrollers we have discussed. One is 8051 microcontroller, and other one is the Arduino family, which consists of Uno, Nano, and Pico. Okay. Now from this class, we started the node MC. So node MC. The node MC is an open source firmware and development kit that helps you to prototype your IoT circuit within a few low script lines. So it takes a power of input voltage 2.3 volts, DC current of 250 megaamps. So memory of RAM 32 KB and DRAM 80 KB, flash 100 KB and node MC it takes. So it is a type of SOC. SOC stands for System on Chip. The non-MCU microcontroller unit is an open source software and hardware development environment that is built around a very inexpensive system on chip called ESP8266. So this was the pin diagram of Node MCU. It was unique, so you can easily understand. ESP8266. So ESP8266 is a highly integrated chip designed for the needs of a new connected world. It offers a complete and self-contained Wi-Fi networking solution. Allowing it to either host the application or to offload all Wi-Fi networking functions from another application processor. ESP8266 has powerful onboard processing and storage capabilities that allow it to be integrated with the sensor-specific devices through its GPIOs with minimum development of upfront and minimum loading during the runtime. So this is how a ESP8266 processor looks like. So the features of an ESP8266 processor is an open source, interactive, programmable, low cost, simple, smart, and Wi-Fi enabled. So as you know, the other microcontrollers need the external Wi-Fi support, but in the ESP8266 it has an inbuilt Wi-Fi. So next pins. It's present in ESP8266 processor. Digital pins of D0 to D10 digital pins. Next, PWM pins are 12 PWM pins present in A0. A single analog pin was present in. Power pins are 5 pins. Next, 3.3 volts are 3, and voltage input is one adding external supply of 5 watts, and it is not connected to an USB. So the specifications of ESP8266. The development kit based on a ESP8266 integrated GPIO, PWM, IC, one wire, and ADC all in one board. USB TTL included plug and play. Then GPIO, every GPIO can be PWM, ITC, one wire. USB TTL included plug and play, PCB antenna. So the other type of microcontroller is ESP32. So ESP32 is the SOC microcontroller which has gained massive popularity. SOC stands for System on Chip. Whether the popularity of ESP32 grew because of the growth of IoT or whether IoT grew because of the introduction of ESP32 is debatable. If you know 10 people who have been part of the firmware development of an IoT device, chances are there 7 to 8 of them would be worked on ESP32 at some time. So before we move into the actual reasons of the popularity of ESP32, let's look at some of the important specifications. So before looking into the specifications, the major what is it, how the ESP32 looks like this. Next, the specifications of ESP32 are listed below. Integrated crystal of 40 MHz, module interfaces of UART, SPI, I2C, PWM, ADC, and DAC, GPIO, pulse control, capacity test sensor. Integrated SPI flash of 4 MB, ROM of 448 KB for routing and core functions. Static RAM of 520 KB. Integrated connectivity protocols are Wi-Fi, Bluetooth, BLE. On-chip sensor, hall sensor, operating temperature range was 40 to 85 degrees Celsius, operating voltage is 3.3 volts, operating current was 80 milliamps of average. So with the above specifications in front of you, it is very easy to decipher the reasons of ESP32 popular. Consider the requirements an IoT device will have from its microcontroller. If you have gone through the previous chapter, you have realized that the major operations blocks of any IoT devices are sensing, processing, storage, and transmitting. Therefore, to begin with, the new C should be able to should be able to interface with a variety of sensors. It should support all the common communication protocols required for sensor interface via I2C SP. It should have ADC and pulse connecting capabilities. ESP32 fulfills all of these requirements. On top of that, it also can interface with the capacity touch sensors. Therefore, most common sensors can interface seamlessly with ESP32. Secondly, Secondly, the microcontroller should be able to perform basic processing of the incoming sensor. Sometimes at high speeds and have sufficient memory to store the data. ESP32 has a max operating frequency of 40 MHz, which is sufficiently high. It has two cores, allowing parallel processing, which is a further add-on. Finally, its 520 KB static RAM is sufficiently large for processing a large array of data on board. Many popular processes and transforms like FFT, peak detection, RMS calculation, etc. can be performed on board ESP32. On the storage too, ESP32 goes a step ahead of the conventional microcontrollers and provides a file system within the flash. Out of the 4 MB of onboard flash, by default 1.5 MB resides as SPIFFS, which stands for SPI Flash File System. Think of it as a mini SD card that lies within the chip itself. You can not only store data, but also text files, images, HTML and CSS files, and a lot of memory within SPIFFS. People have displayed beautiful web pages on Wi-Fi servers created using ESP32 by storing HTML files within SPIFS. So finally, for transmitting data, ESP32 has integrated Wi-Fi and Bluetooth stacks, which have proven to be a game changer. No need to connect a separate Bluetooth module like GSM module or an LTE module for testing cloud communication. Just have the ESP32 board on a running Wi-Fi and you can get status. ESP32 allows you to use Wi-Fi access point as well as station mode. While it supports TCP and IP, HTTP, MQTT, and other traditional communication protocols. It also supports HTTPS. Yes, you heard that right. It has a crypto core or a crypto accelerator, a dedicated piece of hardware whose job is to accelerate the encryption process. So you cannot only communicate with your web server, you can be secure. Clearly support is also critical for several applications. Of course, you can interface LTE or GSM or LoRa modules with ESP30. Therefore, the transmitting data front as well, ESP32 exceeds expectations. Raspberry Pi. So it is also known as Raspberry Pi Pico. Raspberry Pi Pico is low-cost, versatile microcontroller development board from the Raspberry Pi Foundation. It is constructed around the RP2040 chip, which was designed in-house by the Raspberry Pi Foundation. It was released in January 2021, and it's been a very popular development board among the DIY community ever since. Now, a year and a half after the first release, the Raspberry Pi Foundation just released a few variants for the Pico board, namely Pico H, Pico W, and Pico WH. Let's look all of these variants in the differences. Raspberry Pi Pico is a low-cost microcontroller development board from the infamous Raspberry Pi Foundation, available for just $4. The Pico is powered by Raspberry Pi's own custom silicon RP2040 SoC, which features an ARM Cortex M0 Plus processor running up to 133 MHz with 664K of static RAM and 2 MB of onboard storage. A great choice for any DIY project, unlike previous boards from the Raspberry Pi Foundation. The Pico is not an SBC that can run full operating system, but a microcontroller development board that can be programmed in MicroPython or C programming languages. So the Pico board pinout diagram is just like this. So the Raspberry Pi Pico board specifications are as follows. Form factor of 21 mm into 51 mm, CPU of dual core ARM Cortex M0 plus 133 MHz. Memory was 264 KB on chip, static RAM 2 MB onboard QSPI flash. Interfacing 26 GPIO pins, including 3 analog inputs. Peripherals are 2 UART, 2 SPI controllers, 2 I2C controllers, 16 PWM channels, 1 USB 1.1 controller, and PHY with host N. Device support of 18 to QIO state machines, input power of 1.8 to 5.1 watts DC, operating temperatures 20 degrees to 85 degrees. So from beginning, let's start again. From today's topic, Node MCU. Node MCU is an open source firmware and development kit that helps you to prototype your IoT product within a few large script lines. The power, the power input voltage of 3.3 volts, DC current of 350 megaamps. System on chip. The Node MCU is an open source software and hardware development environment that is built around a very inexpensive system on chip is called the ESP8266. The diagram of Node MCU is as so it ESP8266. ESP8266 is a highly integrated chip designed for the needs of a few connected world. It offers a complete and self-contained Wi-Fi networking solution, allowing it to either host the applications or to offload all Wi-Fi networking functions from another application processor. ESP8266 has powerful onboard processing and storage capabilities that allow it to be integrated with the sensor-specific devices rules, GPIOs with minimum development upfront and minimum loading during the runtime. Here it shows the diagram like how it looks like. The features of ESP8266. It is an open source, interactive, programmable, low cost, simple, smart, and Wi-Fi enabled. The, pin, the pins present in ESP8266 are the input output pins, digital pins of pin D0 to D10 of digital pins, PWM pins are 12, analog pins for A0 with a single analog pin. Power pins are ground of 5 pins. See 3.3 volts of voltage between with it. So the one adding external supply of 5 volts, it is not connected to an USB. Applications of ESP8266 are the learning kit based on ESP8266 integrated GPIO PWM, I2C, 1Y, and ADC all in one. USB TTL included plug and play. 10 GPIO, every GPIO can be PWM, I2C, 1Y, USB TTL included plug and play, PCB antenna. ESP32. The ESP32 is the exclusive microcontroller which has gained massive popularity recently. Whether the popularity of ESP32 grew because of the growth of IoT or whether IoT grew because of the introduction of ESP32 is debatable. If you know 10 people who have been part of the firmware development of an IoT device, chances are that 7 to 8 of them would have worked on the ESP32 at some point. So before we dive into the actual reasons of the popularity of ESP32, let's take a look at some of its important specifications. The specs listed below the specs are listed below. So it has an integrated system of 40 megahertz module interfaces, ART, SPI, ATC, PWM, LDC, DAC, GPIO, pulse, counter, capacitive touch sensor, integrated SPI flash of 4 MB, ROM of 440 KB for reading, and core functions. Static RAM of 520 KB. Integrated connectivity protocols are Wi-Fi, Bluetooth, BLE. On-chip sensor was Hall sensor. Operating temperature range of 40 to 85 degrees Celsius. Operating voltage is 3.3 volts. Operating current is 80 megaamps of average. With the above specifications in front of you, it's very easy to describe the reasons for ESP32's popularity. Consider the requirements on IoT device which would have from its method forward. If you have gone through the previous chapter, you have realized that the major operational blocks of an IoT device are sensing, processing, storage, and transmitting. Therefore, to begin with, the microcontroller should be able to interface with a variety of sensors. It should support all the common communication protocols required for sensor interface, UART, I2C, SPI. It should have ADC and pulse counting capabilities. ESP32 fulfills all of these requirements. On the top of that, it also can interface with capacitive touch sensors. Therefore, most common sensors can interface seamlessly with ESP32. Secondly, the microcontroller should be able to perform basic processing of the incoming sensor data, sometimes at a high speeds and sufficient memory to store the data. ESP32 has max operating frequency of 40 MHz, which is sufficiently high. It has two cores, allowing parallel processing with which is further add-on. Finally, its 520 KB static RAM is sufficiently large of processing a large array of data, data on many popular process and transforms like FFT, peak detection, RMS calculations, etc. can be performed on board ESP32. On the storage front, ESP32 goes a step ahead of the conventional microcontroller and provides a file system within the flash. Out of the 4 MB of onboard flash, by default, 1.5 MB is reserved for Finally, its 520 KB static RAM is sufficiently large for processing a large array of data on board. Very popular processes and transforms like FFT, peak detection, RMS calculations, etc. can be performed on board ESP32. On the storage front, ESP32 goes a step ahead for other conventional microcontrollers and provides a file system within the flash. Out of the 4 MB of onboard flash, by default 1.5 MB is reserved as SPIFS. SPIFFS stands for SPI Flash File System. Think of it as a mini SD card that lies within the chip itself. You can not only store data, but also text files, images, HTML and CSS files, and IoT more within SPIFFS. People have displayed beautiful web pages on Wi-Fi servers created using ESP32 by storing HTML files within SPI flash file system. So finally, for transmitting data, ESP32 has integrated Wi-Fi and Bluetooth stacks, which have proven to be a game changer. No need to connect a separate module, like a GSM module or an LTE module, for testing cloud communications. Just have the ESP32 board and a running Wi-Fi, and you can get started. ESP32 allows you to use Wi-Fi in access point as well as station, while it supports TCP or IP, HTTP, MQTT, and other traditional communication protocols. It also supports HTTPS. Yeah, you heard the term. It has a crypto core or a crypto accelerated, a dedicated piece of hardware whose job is to accelerate the encryption process. So you can not only communicate with your web server, you can do so securely. Really support it is also critical for several applications of course. You can interface LTE or GSM or LoRa modules with ESP32. Therefore, the transmitting data content as well ESP32 exceeds expectations. So, up to today's topic, is there any doubts? Feel to raise hand if you have any doubts. guys. Hope all understood today's session up to the topic. Or should I start from the microcontrollers from the starting? Is the response diagram. A single guide is to the response to today. I did a response from you guys. Guys, I need response to continue the session. If the class is clear or you are having any doubts, is the class understanding or not understanding? Everyone is understanding the class and no one is having any doubts. So the final, like for the topic of which we are using in the embedded system, the one of the type of the microcontroller, the Raspberry Pi Pico. So Raspberry Pi Pico is the lowest versatile microcontroller development board from the Raspberry Pi Foundation. It is constructed around the RP2040 chip, which was designed in-house by the Raspberry Pi Foundation. It was released in January 2021 and it's been a very popular development board among the DIY community ever since. Now, a year and a half after the first release, the Raspberry Pi Foundation just released a few variants of Pico board, namely Pico H, Pico W, Pico WH. Let's look at all these variants and their differences. So, Raspberry Pi Pico is the first low-cost microcontroller development board from the infamous Raspberry Pi Foundation. Available for the just $4, the Pico is powered by Raspberry Pi's own custom silicon RP2040 SoC, which features an ARM Cortex M0 Plus processor running at up to 133 MHz with 264 KB of static RAM and 2 MB of on-boot storage. A great choice for an DIY projects. Unlike previous boards from the Raspberry Pi Foundation, the Pico is not an SBC that can run a full operating system, but a microcontroller development board that can be programmed in microprogram or C programming languages. So here you can see the pin out, pin in out of the Raspberry Pi Pico. So Raspberry Pi Pico board specifications. So this is the end of session for today, guys.